Okay, so you should have seen video 1 in which we did a quick overview of notes over domain and range. And now we're going to start with our example. So example 1, we're going to do our domain and range. The first thing you should be able to tell me based off of video 1 is if this is discrete or continuous. Now remember, discrete, you're jumping from dot to dot, right? Or it's disconnected anywhere in between the beginning and the end. Continuous is you can slide all the way through your journey without stopping until you get to the end. So you can see from here we have dots. To get to this dot from that dot, you have to jump. So we know that this is a discrete example, okay? Now, let's think of Dr. XY, right? Domain X, range Y. Okay. So we want the domain. Okay. In order to get the domain out of these points, we're going to have to write them out first. So we have this first dot right here is at -3, 1. Remember, this is our X side, our Y side. Our next dot, this one right here, the X value is -2 and the Y value is at 0. Our next dot would be at 1, 4. Then our next dot would be at 2, -5. And then our last dot would be at 5, 1. Okay, so 1, 2, 3, 4, 5 ordered pairs. 1, 2, 3, 4, 5 dots, 5 coordinate points. Okay, so from here, you have domain X, range Y. So your domain is the X values, which are on the left side. So -3, -2, 1, 2, 5. And they happen to already be in order from least to greatest. So -3, -2, 1, -3, -2, 1, 2, 5. For your range, well, your range is your Y values, which we happen to have them written down already. Now remember, we want to go from least to greatest. So my least is -5. Then we have 0, 1, 4. Now, if you can't just look at that, you can write it down, right? So we know the range is, I see a 1, a 0, a 4, a -5, and a 1. So -5, then we have 0, 1, 4, and there is your range. Okay, so that was example 1. Example 2. Okay, it's right here. So this is going to be our example 2. Now, this right here, from here to here, I can slide. I see 2 dots. Just because I see dots does not mean it's discrete. I can see dots or no dots. So there could be dots right here if the problem wanted to, right? That does not make it discrete. Because I can go from beginning to end, right? Sliding through, I know this is a continuous example. Okay, so remember, we need to think of Dr. X, Y, dx, and ry. So the domain, we know domain is the x-axis, which is left and right. So make sure you're writing that down. Left and right is the x, left and right. And I want to create a border so that it's still touching my graph, but it's not going to cross it. So where would that border go? So it looks like it would go right here. And that's a good border right there. It's still touching my graph. It's not cutting my graph, and my graph is not going to go past that border. So that is a really good border right there. So what is that number? Make sure you're taking into account what number that left border is. Now let's go to the right side. Can I create a border here? Well, yes, I can. And notice that I'm drawing my lines all the way. Okay, so here's my right border, and there's your number right there. Okay, so I have two borders in my graph. My X values are in between these two borders. So your domain, you're gonna grab your left border, which is -5. Your X is in the middle because your graph is in the middle, right? Your X values are in between these two, and your right border, which is a +5. Now, if you remember from video 1, we talked about you needing to use your inequality symbols. Now, why are we using these symbols? Your X values, right? This graph is bigger than -5. Your graph is on the right side of this border, so that's why you have to use that symbol there. And your graph is smaller than this border, which is right here, which is why you have to use the less than symbol in both places, because you're saying that your X is in between both of these borders. Okay, this graph is going to be bigger than that border but smaller than this border. Okay, at this border, it is a closed, so equal to, closed, equal to. So your domain is from -5 to 5 and everything in between. That is what you are telling me right there. Now, let's do the range. So your range, right, is the Y. Well, which way does the Y travel? Up and down. So low to high. Remember, always start at low and go to high. So low, high. I wrote this too big. Okay, low, high. So same thing. You're going to draw your low border. Where can I draw this border so that it doesn't cut my graph, but it touches it? So right there. Now, this low border, where is that number at? Okay, at that -2. Now let's go to my high border, and it's at a +2. So your Y values are in between -2 and 2. Again, you're going to look at your graphs at this orange border. Where does it touch? They're both solid. It's a close dot and a solid line. So it's going to be equal to at your -2 border, and at your +2 border, it's also going to be equal to. So there is your domain and range. Okay, that was example 2. Now let's go to example 3. Okay, so here's example 3. So, same concept, right? You're gonna do your doctor X, Y. So you know your D is domain, which is X values. So we're going to use our left and right border because that's the way the X axis travels, left to right. Remember, the goal is to give it borders so that your graph is contained. So let's start with our left border. At this right here, so it looks like my border should go right here. Now, is your graph going to go past that border? No, so that is a good border, okay? Now let's go to the right side. If I draw a border right here, I have an arrow. It's not a dot. So what do arrows do? They keep going. So can I draw a border on the right side? No, there's an arrow. No matter what border I draw, this arrow is going to pass all of them. So there is no border I can draw that will contain it and stop it. Okay, so it will keep going. So there is no border on the right side. Well, what does that mean? It's okay. That just means that this is the only border I have, which is at -4. Okay, so our domain is x values, and we have the number -4. Now, where is it going? Notice that I wrote my x first because I only have one border. So now we have to figure out, well, where is the graph going? Well, from our border, is the graph going to keep going to the right or the left of that border? Well, it's going to keep going to the right. What is right? Greater. So we're going to use the greater than symbol. Okay, now remember, if you forget what that symbol is, if it looks like an L, it's the less than symbol, right? So I don't want the less than symbol, I want the greater one. So it has to be the one going in the other direction. Now, at this dot, is it open or closed? It was an open dot, so that is your domain. You leave it alone. So x is greater than -4. So your graph, your x values are bigger than the -4, and you can see that. All of these values, right, as you travel the graph, they're all going to be bigger than the -4. Okay. Now, let's do our range. So at the range, we know we want low, high. So if I draw a low border down here, is this a good border? It looks like it might be. It looks like, well, I have a dot right there, so it must be a good border. But what do we have over here? An arrow. And what do arrows do? They keep going no matter what. So can I ever actually draw a bottom border that will stop this graph? No, you can't, because of this arrow. It's gonna keep going. So do I have a bottom border? No, no bottom border. No border at the bottom. Oops, border. No border, okay, because of the arrow. Well, let's go to the high part, right? Let's go to the top. Can I draw a border up here? Is this arrow going to stop me? No, because the arrow is going down, not up. So can I have a border here? Yes. So what number would that be? A +1. So your range is y, and we have a border of 1. So from this border, where is it going? Is it going above the border or below the border? This graph is below the border. So below, less, I want my symbol to look like the L from less. So I'm going to use the less than symbol. Now look at the border. Where does it touch the graph? Both of these are solid dots, right? They're filled in, they're closed circles. So that means I have to have an equal to. So your domain and range. Okay, example 4. Okay, let's cover this up so it doesn't like throw us off. Okay, so example 4. Here we go. Same thing, you're going to start noticing that the process is the same no matter what. The whole point is you want to see, can I draw a border there? Yes or no. If you can't, then you go to the other side. And if you can't there, you're about to see what happens. Okay, so again, we know we're doing Dr. X, Y. So for domain, we have left, right. On the left side, can I draw a border? I have an arrow, and it's going to keep going like this to the left, little by little by little. So can I draw a border there? No. I have another arrow here. So can I draw a border on the right side? It's going to keep going up and up and up and up, little by little by little. So can I draw a border there? No. What does that mean? It means you cannot contain this graph from the right or the left side. You cannot contain it. So that means that the domain is all real numbers, because you cannot stop it. It means that every single number on the x-axis will get used. It will get covered, okay? There's nowhere where you can cut it because everything will get used. So for your range, okay, let's do the same thing. We have low, high. Well, the low, okay, well, here's my low. So can I draw a border down here? It looks like I can draw a border right here, and it's touching this W looking shape, okay? So at this W, it looks like it's sitting right at the x-axis. Don't let that trick you, right? Because we want the y value. We're doing range. Okay, so we do not want to look at the -3 and the 1. That's the x's. I don't want x's. I want y. So what y value is it crossing at? It's crossing at 0. Anytime it looks like your border is the x-axis, that's actually 0. So I know one of my borders is 0. Okay, now let's do our top border, our high border. But I have arrows here, so can I draw a border to stop this or to contain it? No, I can't, because those up arrows are going to cross it over and over and over again, no matter how many borders I draw. So we only have one border for the range, and that range is y, and that border you found was at 0. We saw the up, right? And what is up? Greater. And is it equal to? It is a solid line. If you will notice that there's no closed or open dots. That's because there's a solid line. A solid line is composed of a whole bunch of closed dots. So equal to. So your range means it's going to go above the 0, which it does. It starts here and it goes up forever and ever and ever. Okay, so there is your domain and range for example 4. Last example. Okay, so this is the last one we're gonna do. Okay, okay, so this is the last one we're gonna do. Here, let me do this. There we go. Okay, so remember, we know Dr. X, Y, and domain range. So for our domain, we want left, right. Well, if I draw a border here, there's an arrow. I cannot do that. So no border on the left. If I try to draw a border here, there's an arrow, no border on the right. What does that mean? It means that our domain is all real numbers, because these numbers are never going to stop because of the arrows. Well, now for our range, we have a low and a high. Now you notice that it's already a perfectly horizontal line, right? That happens to be, it almost looks like it's our low and our high, which can be a little confusing. But remember, the range is y values. What y values are going to happen? Well, the only y value that's going to happen is at 3. So your range is only going to happen at 3. So y equals 3. Ta-da! Hopefully this helps, and go do your quizzes homework. Thank you.